Now, all this talk about strong and truthy equality, I know is fascinating. I know you're riveted, but we're here talking about MongoDB, right? What does all of this strong and weak typing have to do with Mongo? Well, in fact, there are two reasons why Mongo is such a strong part of the mean stack. And the first aspect of this is that if you use Mongo for your persistent solution, it reduces, or dare I say it, even eliminates the language impedance mismatch that we were dealing with when we first started talking about this. If you're writing your queries in SQL but your application in Java, you always have to be doing some form of context switching. And as we'll talk about in just a little bit later, what we'll find is even your models, if you're doing class-based inheritance versus relational, the modeling will introduce impedance mismatch. But let's talk about the language impedance mismatch, or the lack thereof, to begin with. At the end of the day, Mongo is really nothing more than a durable, persistent JSON store, which means that what I get to do is define JSON literals or object literals like you see here. I get to say, name is Sue, age is 26, status is A. But look what we do then. The groups that Sue is in, news and sports. If we were trying to store this in a relational database, we would have to do some transmogrification on this data. We would have to convert groups into a one-to-many relationship, and then would need primary keys and foreign keys and relationships. And what if we just decided to persist this as you see it on screen? This is perfectly valid. I can take this JSON object that has full fidelity in JavaScript and save it as is in Mongo, and we've got full fidelity there as well. And the query language that we'll see takes into account the nature of JSON. For instance, if I'm writing queries and I say, give me all of the people who are in the sports group, Mongo will naturally reach into these embedded arrays, pull out the value that I want, and give me the results. I don't have to care if this is a simple value or an array. I don't have to care if it's an embedded subdocument or a field hanging right off the top. So what we have is we've got a fuller, more language fidelity respecting persistent solution in Mongo. And you'll see the query languages are expressed in JavaScript as well. When we see db.users, users is our collection. This is analogous to a table in a relational database. But a collection is a collection of documents. And so when I say db users, I want to find all of the documents where age is greater than 18 and sort them by age. You can see I'm expressing that query in JavaScript, not SQL or some other language. When I'm doing an insert, when I do a db users insert, again, I am taking this document and inserting into the users collection. We saw this in a previous slide. We see that we can take any JSON and simply persist it. Of course, we have db users update and db users remove as well. But the query language allows us to do more sophisticated things like aggregation. So at this point, I can say, all right, give me all the people who have a status of A, but then group them by the ID and sum up the amount field. And all of a sudden, we've got some really sophisticated things going up, all expressed in JavaScript. Different set of APIs on this particular platform, but the core language remains the same. We even have the required MapReduce example right here, whereas mapping is much like the first portion of your SQL statement. When you say select first name, last name, city, state, and zip code from customers, that's like the map portion of a SQL query. When you say select first name, last name, city, state, zip from customers, where state equals Colorado. That where clause is like the reduce clause where you apply some criteria to it. And so you can see in this case, we can select, we can map, we can reduce, we can even transform the output. And since we're in a dynamically typed language, we will very often transform this data. It's very easy to not just get raw JSON out of this database, or BISON, which is binary JSON, but allow us to completely transform this output. Turn around and give me the output that I'm looking for, not how it's persisted or not how even the persistence store represents the data. And this is where we get to the second aspect of Mongo. Not only does it reduce or eliminate the language impedance mismatch, it also reduces the modeling impedance mismatch. We're not dealing with an object relational mapper anymore because we're just dealing with durable, persistent JSON all the way through. So what that means is as you're modeling your data, you're going to lose some capabilities, but you're also going to gain some interesting new superpowers. So one of the things that I've found, and team after team, as we move from a traditional relational database to a document NoSQL solution, one of the things I hear over and over again from my developers are, oh my gosh, all of a sudden I feel a lot more agile. You've heard the joke about the DBA that went on a first date, didn't you? DBA went to the bar, met a beautiful woman. He said, how do you think things are going so far? And she looked at her watch and said, well, it's pretty early in the date, but I'd say so far so good. He says, great, I just wanted to make sure. Okay, I can see that we're going to date for another 18 months. And around March of 2017, we will actually get engaged. It'll be a very short engagement whirlwind. We'll be married within 6 months. We'll have our first kid 8 months after that. 8 months, you caught that. And then the next kid 16 months after that. And the third kid, if we're up to it, 36 months after that. Why would a relational database expert date in such a way? Well, it's because you have to have perfect knowledge of the future, don't you? If you are going to define every field, every data type down to the character before you even start writing your application. MongoDB takes the opposite approach. Since it's just simply durable JSON, you can start with what you think your application looks like in iteration 1. In iteration 2, you can make changes to that. In iteration 3 and iteration 4. And MongoDB simply follows your agile, iterative data modeling process happily. Happily. We find that MongoDB gives you the familiar primary keys you'd expect to see, but there are no joins in MongoDB. There are no joins. And so you say, well, wait a second. How do I represent one-to-many relationships? Well, you can still have one-to-many relationships. You can use primary keys and foreign keys as much as you'd like. But in fact, sometimes it's more natural not to represent it as a one-to-many, but perhaps embed that in the document yourself. If I am trying to deal with a person, and that person has a phone number, well, why not embed the phone number directly in the person document? Why go to the process of having a one-to-many relationship when you can include the phone number directly? And if you want to model it as a home phone number and a work phone number and a cellular phone number, we can begin having arrays of embedded subdocuments as well. I like saying that JSON and Mongo by extension does a better job of helping me model my domains. Because when I think of, say, an invoice, I think of an object, an invoice object, that has line items embedded inside of it. I don't think of it as an object that I'm going to need to make multiple queries to join in after the fact. It allows me to represent an invoice as a more natural, real-world representation of what I'm trying to deal with. So, yeah, we don't get joins. So what that means then is that sometimes it's okay, and dare I say it, appropriate, to denormalize your data. We're not worried about disk space in the 21st century. If you need to very often query on something that requires a keyword or another ID, just go ahead and denormalize it and add it on the document. It's gonna be okay. That duplication is going to make your application easier to work with, and that's okay at the end of the day. Many times your one-to-one relationships go away entirely because we have subdocuments. But even if you do have a true one-to-many relationship, one conversation comes up very frequently when you're using MongoDB. And that question is this in fact a one-to-many relationship, or perhaps is it a one-to-few relationship? Because that will determine how I model that data set. If I've got a household that I'm dealing with, that at most will have 2, 3, 4, maybe even half a dozen family members, I might choose to represent that household as a one-to-few relationship and embed those household members directly in the household. I might also determine that, no, there are some times when I want to deal with the household, but sometimes I want to deal with the household members independently. That's when I can create a one-to-many relationship. I can still create the links because of primary and foreign keys. So I have now the ability to say, if I'm modeling the city of Denver, I don't think that I'd want to include all the citizens within that document because it would literally be millions of records, and I would probably want to deal with those citizens outside of the context of the city they live in. I'd want to represent that as a more traditional one-to-many relationship. But maybe I would want to represent counties containing the cities, or the state containing the counties. I have the ability to model it in a way that more closely matches my domain and more easily enables the programmer to accomplish what she's trying to get accomplished. So even though we have some new idioms to play around with, we still have many of the same idioms that you're used to dealing with. Indexing, regardless of whether you're dealing with a relational database or a NoSQL solution, is crucial for performance. And indices work the same way in both. If you're going to query very commonly on a social security number field, or a last name field, or a city field, regardless of where it is or it's denormalized or not, create an index on it and that will definitely give you performance enhancements. Clustering and failover is the next way to deal with this. Mongo, just like a relational databases, supports clustering out of the box. You can build a cluster as many node instances as you would like, and at some point you might decide to shard or partition your data across the machines in the cluster. All that is available to you here. So in some cases we have a new way to deal with a new persistence store. In other ways, our persistence store shares many of the common characteristics that we know and love about our trusted persistence solution. But more than anything else, I want to make sure that you're not afraid of change and you're not afraid to embrace technologies that are a better fit, not only for the solution, but for the development tools you're using. Choosing a persistent solution that reduces language impedance mismatch, that reduces modeling impedance mismatch, is altogether a good thing. And if you go back to highscalability.com and look at what a lot of these major players are dealing with, it is remarkable how few of them are using our favorite golden hammer relational databases under the covers. Now be very clear once again, I'm not telling you never to use a relational database. I'm telling you to use a relational database where a relational database is appropriate, but be open to other persistent solutions that might be a better fit for the entire technology stack that you're using.